Hello everyone, this is Yuwei and this is my Stats 512 final project. So, as we all know, picking out the right university for higher education can be a really difficult choice. Depends on the college's like location, tuition fee, and the overall alumni employment rate, and the quality of the faculty and the quality of the education. And as the overall college enrollment rate is increasing at both 2 years and 4 years institutions between 2000s and 2018, picking out the right university to attend can be a tough choice, since decision need to be made based on like all these criterias. So we often look at the overall college ranking to pick out the right university, and the Times provides one of the most recognized and the most influential and most well-known and accurate world university ranking uh, among all the other places that also do the ranking. And Times also do update their data set like every year. This data set is features the ranking of the world top 2,000 universities around the world based on all these criteria that we'll mention later from Times. But personally, today I will only look at the top 200 universities in the world. So, in the author's original research question is to see out of all these universities in the world, which one is the best. So what he did is he had like a overall ranking score, which is gonna be the Y, like the response variables, like in this presentation. So he has like all different, like all 7 different criteria, like variables that he was looking at, and then eventually will add up to a score, and then whichever university has the highest score, he considered that as the best university in the world. So that was his original research question, and then for me, I'm gonna be looking at like the null hypothesis will be beta 1 equals beta 2 equals beta 3, 4, 7, 5. And then a alternative hypothesis will be beta 1 not equal to beta 2, beta 3, beta 4, beta 5, beta 6, and beta 7. So this is what the author used to rank his final score. This is the 7 variables that he looked at. So it's quality of the education, alumni employment, quality of faculty, publications, influence, citation, and the number of patents. So overall, so this is eventually all these 7 variables that will add up to the final score, and whoever has the highest final score will be considered as the best university, which in this case is Harvard. So I started building my original linear model. I just transformed kind of like all the variable names to x1 and x7, just so that it is a little easier for me to do the R code thing, because sometimes like when you have to type out like 20 words in R, sometimes you can mess with that. And then my data set is called final one. So this is my model summary. So from the model summary, we can see since the F score is very high, and I think this data is not the best, because since like I mentioned, this is like a score based data set. It has like almost like a ranking, since it goes from like top to the highest to the lowest. So after I got the summary analysis, I started doing module plots. So from the normal QQ plot and the residual plot, we can see that all these data, they are not like centered around 0. So we know this data doesn't have like constant variance. And I can also draw the conclusion to say between the predictors and variables, it's not like a linear relationship. from the normal QQ plot and the fitted residual plot, I can also see very significant outliers. And I think that's because, like I mentioned, um, this data set is like a ranking data set, so it's going from the highest to the lowest, and like the top like 5, the top 10, it's always gonna be the ones like significantly higher than the rest of the data sets, and that's why I'm having like all these like severe um, outlier issues. And now, so I ran like more tests to try to see if there's other problem with my model. So I did a Shapiro-Wilk normality test, and I find out that like since I have such a small p-value, I can draw the conclusion in my data is basically normal. But my data, like the model doesn't have constant variance, like I mentioned, because um, the residual plot show us like the data does not center around 0, and I can see a pattern in my data, so that's not a very good one. And then I can also see the relationship between the predictors and the variables is not linear. So um, for the VFF, I don't have anything that's greater than 10, but I do have everything that's all greater than 1. So we can say like I want to draw the conclusion saying there's not like a severe multicollinearity issue, but the model is definitely not good. And the model definitely has some minor multicollinearity problem. And now after I did like find the problems in my existing model, I started to like try to transform my data and try to find like how can I improve it. So for model transform, I did Y. I transformed by Y, and then I also transformed 3 of my X variables, since the model doesn't have like a constant variance. I transform like x4, x5, x6. So after I transformed the model, I did like a remedy analysis. I first did like a weighted least square analysis like on my module, and I also did like a ridge analysis, try to find the best lambda that will give my model with the best cross validation. So I ran the test and I find out like if my lambda is 0.38, and then that model when lambda is 0.38, that will give me the best performance in cross validation. So like I mentioned earlier, my model has some minor multicollinearity issue, and so in order to reduce that, I did a continued remedy analysis. I used the ridge analysis to find out the best lambda I can find, and then to kind of try to reduce my multicollinearity issue. And after I run that, I can see like when lambda is 0. That's when I have the best sets. That's when my model perform the best, and when lambda is 0, that's when I can actually reduce my multicollinearity issue of my dataset. And I also did like a robust regression just to see to find more problems and try to fix my data. And the residual standard error is really big. And then later I want to see if I can like transform my model by building a new model, like because I want to drop like couple like variables, and that's my next step. I try to do a new model and try to drop beta 4, beta 5, beta 6, and I did a ANOVA analysis on the reduced model, which is just x1, x2, x3, x7, and then like a full model, which is the original one. But unfortunately, I cannot drop any of the predictors. so I have to reject the null hypothesis because this is also kind of upsetting to see, because I was hoping I could drop something and make a new model that could like see a little difference compared to the original one, but it just did not happen. Like I tried multiple ways to like transform the data, it just didn't happen. I also did a k-fold cross-validation analysis. So like the reason why I do that, like k-fold cross-validation has like a big advantage because it repeats data, but in each repetition the data sample is shuffled, which the result is developing splits of the sample data. So yeah, and after I ran that, it gave me the RMSE square of like 1575. And the next thing I did is, since I couldn't like actually improve my model by dropping any data, what I did was I just after I transfer my data, I run the final model and conclusion. So even though like the model is not really like improved that much of a difference, but I compared to the original model, like the data is slightly more centered to, like around 0, and like it's more of a linear relationship now than it used to be compared to the very first model. And then my final conclusion is this is still the model that I have to use, since I cannot drop anything, since I can't drop any predictors like from this model, and I failed to reject my original hypothesis saying that all beta is like equal to 0. Okay, thank you.